Hello. How are you?
I'm all right. How are you?
Good. Good. Finally done traveling all around the country, but a little
Uh,
bit sad because our team lost. So,
oh, so you came Sunday?
yeah.
Okay.
So, just trying to like reset my sleep schedule and my time
Okay.
zone calendar and everything.
Yeah, that's fair.
Mhm.
Hopefully, they're not going to be so up your butt with classes for a little bit because of just getting back into the groove of things. But
Yeah, hopefully. Um, I know I haven't gone to my one class in like a month because of spring break and it's only once a week. So, I'm just kind of like, oh, I'll show up tomorrow, see what the professor says.
yeah, see what happens tomorrow.
Yeah, but
How's thesis
it shouldn't be
writing
too bad.
coming along?
Good. I finished my first draft, so that was like a nice feeling. And I'm taking a break from it for like 2 or 3 days, and then I'm gonna try to go back and start editing.
Hmm.
Um, but I'm getting like feedback and stuff from people. So
That's good. Your draft is due next week or
my draft was due yesterday. The final version's due
oh,
the 16th. So what's that, like 2 weeks?
yeah, that's not bad. Okay, that's good.
Yeah. How about you?
Um, Going well. Weather's crappy again. Shocker. It's wet and cold today, so I'm wearing my comfy. So, because I'm
Do you want to
just,
know what the high is here?
I don't know if I want to know. It's like 70s.
83 degrees.
Okay, well that's nice. Want to send
Yeah.
some north? Like
Yeah. Just like a little bit north,
a little bit. I
a
would
lot
love.
of bit north.
It's just so disgusting here, and I just wanted to be nice, but it's also like helping me stay inside and just at my computer rather than dreading to go to the park or something. But
Mhm.
I'm just excited to bring out my hammock, go to the park, meet up with friends, and just read. Like that's what we did last summer, and I have been so behind on reading my books. So I'm
That's
excited when
awesome.
it starts going. It's gonna be nice. Just want a hammock and read. Like that's all I
That
want to
sounds
do.
great.
So that's what I'm looking forward to. Hopefully it'll be nice by the end of the month, but who knows with Western New York. Um, Otherwise, migraines, I don't know if it's because of my stress or because of the weather. My migraines have been more prominent. So I've been trying to work with that. And also I'm trying to make my schedule more adaptable to what is expected for test day. So, like, waking up at 6 a.m. and whatnot, and then kind of being able to tone it down by 4 or 5. But that has been very unsuccessful. So I'm still on the 12 to 12 p.m. to a.m. cycle. But I'm like, you know
Hmm.
what, whatever. If it works, it works. And it's not going to be too reflective upon time. And it'll probably be better within that last week anyway, when prep has been more like on the lighter side, if that makes sense. So,
Yeah. I would just
mm,
like, if you want, try to like scooch it up a little, like little by little. But
yeah,
I feel like what's really important is like the like 3 or 4 days before ish period.
yeah,
Um,
agreed.
yeah. Because I don't know, I feel like I've been traveling in like different time zoning and stuff, and it's like it's usually pretty fine in like 2 or 3 days, just kind of the same deal.
I was hoping 2 weeks kind of just to give myself more of that recovery time, but I think it's just me because I hate mornings and I need to like fully recoup until like 12 or 1 and then I'm like in the zone. I can manage it and I'm a night owl, so working into the evening is no problem for me. It's just the morning that sucks. But
Hmm.
that's
Yeah.
I still hate the fact that they no longer offer the exam in the evening. Like they did that when I first was studying like a couple years ago, and then they decided to only have it in the mornings, and I don't know why, but that would have been
Yeah.
so in my favor, but it's fine.
Yeah. I know some people too, like need time to like wake up their brain or whatever.
Mhm.
So I mean, not that that'll kind of make you wake up earlier, but
No, I
I
know what you
feel like
mean.
you'll figure out what works. Like, I don't know, like my sister would definitely be like, roll out of bed, start the exam. But like, I feel like I like to have a nice little leisurely breakfast. I'd like to do a
Mhm.
little like um, walk around the block with the dog.
Yeah.
Um, yeah, when I took it, it was like a 30-minute drive away. So that was like a nice, like, listen to my favorite music kind of thing. So, you
Yeah.
know.
I was thinking of since I want to keep my lunch and like just food light. So I'm just more like not focusing on that, but like going even just to the grocery store beforehand so I can be more active. And that would also help me just to be more aware of what's going on outside of the testing center. And the testing center is like not even a 10-minute drive from here, and the grocery store, which fit in with that 10 minutes anyway. So I was going to do that last time and then that didn't work. So I'm going to do that this weekend and pretend like I'm mocking basically next Friday and pick what I was going to do, eat, drink, and then make a detour to the testing center. Like I'm going there, but I'm really going to a different location to take my test, at least for this weekend. So like get that in. I usually put in like some empowerment, confidence music and just blast it in the morning anyway, or as I'm more awake, I turn up the volume. So then it'll be easier for me to get in that mindset. So that was like that has been my routine for weeks, but the grocery
Mhm,
store seems so it'll be fine. Like you getting frustrated with cars because I don't know what really I've just like been exploring and reading through on how to improve on it, but I'm like
mhm.
more or less giving up on trying to improve.
Well, I mean, so what was the most recent one? It was like a 121, right?
Yeah, so I mean, I improved from the previous, so yay. And also for the good chunk of the passages in reading or regarding cars, they were all like above 60% a take of accuracy, minus maybe one or two that were about 50%. And then two of the passages were absolutely butchered, like one out, and they were ironically the 2 7 question passages because I saved those for last. So I know I can get the easier ones out of the way.
Hmm.
And I didn't have enough time to review one of the two, and then the other one I just barely looked at. So I don't know if that was a smart way to do it, of saving the 7 questions last. And that was my plan going into the exam anyway, and hit the 5 and 6 questions on the dot. So I know I got those points. I think it's just more of me worrying that the 7 question passages are going to be more of the difficult and harder passages. But I don't know if they do it for all of the exams of putting all the difficult passages in the middle of the section or if they spread
Hmm.
it out more because like we both talked about jumping around. So I was like going from the beginning, did a little bit, and then once I started getting more into the more of the wordy passages, I went started from the back and then I worked my way backwards. And that helped to kind of gather more of the easier passages. And then to start
Hmm.
getting harder as you approach the middle. Um,
Hmm.
I don't know. I've just been working with that, and I've also been bouncing back and forth between AMC and U World, trying to see, like, pinpoint if there's something that I can correlate with the passage to the questions. Some are easier than others. I don't know. I really don't know.
Hmm. Yeah, yeah. I think this is always kind of the hardest part because it's like I don't want to say that you've like maxed out where you could be, but it's like it's hard to see what could be done to like
I know.
significantly change that. Like if you're able to keep yourself at that 121 consistent level and get through the sciences, then like you can still like that could be compensated for by
Right.
doing better on the sciences. Um, I don't know, because I feel like part of what's happening is like it's like a self-fulfilling like thing where you're like, oh, I'm not that good at cars, and then you take the test and it's not that like it's not necessarily going up, and then it's like, I don't know. I feel like it's all very mental. And that's the part that I like don't necessarily know how to like
I know.
change.
Yeah.
Um, so I think maybe if we spend a bit more time focused on the sciences and the other three sections and just let cars be, like continue to do the cars practice and review those as well. And then just kind of let it like stir in the background for a while and then see what
Exactly.
happens.
Yeah.
Like, take this week and be like do your cars practice, but be less focused on like trying to improve or change, like just do them as you know and with the strategies that you have, and then just see kind of what goes from there, um, while you're focusing in on like other sections and just making sure that you nail down just the little things that are going to make the difference between like that 126 and like a 128 or
Right.
something like that.
Yeah. I
um,
mean, that was basic. That's ironically, that's also what my dad was telling me is like cars, you
mm,
don't, it's stupid. Like you can't really go off it. It's just what it is in front of you. And again, my reading comprehension has always been so poor. So if I can only do so much about it. But then I'm like, well, different strategies, mainly kind of treating it like a pop quiz, which kind of has been helping like in that 10-minute mark. But I don't know if it's beneficial for me to save like those longer questions towards the end, or should they be attacked straight up? What do you think?
I mean, do you feel like by the end of the test that you're really getting hit with that like fatigue,
Like end of the, what do you mean by
or
like,
end of like when you're getting into the longer passages, like is that when like the test fatigue is also hitting?
I mean, based on this past test, no, like I felt worn out after cars, but that didn't, but that break, the 30-minute break made me kind of re-energize. Like it helped me build myself up back to a level where I can go through bio and psych as normal. I think it's more of the lengthiness of the questions that intimidate me and make me want to move on or come back to it, especially if
Mm-hmm.
I glance over the passage and I see, oh, this is going to be economics based. I'm going to be like, yeah, hell no. We're going to move on to something more of a humanity based or literature because those are the easier ones to comprehend, at least for me. But
Mm-hmm.
um, I don't know. Ironically, though, this past exam, I did better on the social sciences questions than the humanities. So I don't
You
know.
never know.
I don't, yeah,
Okay.
literally, it's just as it comes, I'll take it as it goes and just go with it.
Okay. Because my potential suggestion was going to be like, because what I don't want happening is basically like one passage influencing how another passage goes.
Yeah.
So if you feel like you're generally like, I feel like I'm able to kind of separate each passage out and like start with a blank slate every time, then like I think that's fine. I don't think you really need to change how you approach them. But like, if it does feel like, wow, I know I did kind of bad on that passage, and then that's like you're bringing that into the next passage. I was thinking of a strategy where you do like 10-minute timed, 5-minute break, 10-minute time, 5-minute break, 10-minute time, 5-minute break for, just a couple passages just to like
Mhm.
get up, walk around, like mental reset, and then just like get into that habit of like clearing out what happened in the past passage. Like you're not even looking at the results, you're not looking at what happened, you're just pausing for 5 minutes and then coming back and kind of starting with a fresh outlook on the
Wait.
passage. And then when you would do that in like order, or like in the test without breaks, hopefully it would be that same kind of like,
Reset.
reset. Okay, I just,
Yeah.
close
I've
my
just,
eyes for 15 seconds, something.
I mean, it's been easier for me lately just to like differentiate, like separate myself from passage to passage. I've just been doing it more on time just lately, as within the past couple ones, if you have seen the sheet, because I just want to make sure that I'm like on the right track of where I need to look for answers. And it's so varied, like 50% of the time I'm like, I'm right there. The other time it's like, if I could have just read a little further or backtracked, I would have been there. So it's like, I'm either nearly there or I'm spot on.
Mm-hmm.
So I don't know. I'm just taking it as I can and just like
Hmm.
crossing my fingers and moving on.
Yeah. Okay. Yeah. I think just then taking this week to be a little less like cars heavy, and we'll see what happens when we come back to revisit it. I don't know. I feel like at this point, it's like the more we focus on car strategy, the harder it gets.
Hmm.
So, um, the best idea is probably just like
Back off.
step away from that for a bit. Yeah.
Even that might
Um,
help. Who knows? Like just not being
yeah.
hyper focused.
It's like, I feel like what happened, at least with your kind of cars journey from our tutoring, was like it kind of spiked at first. It was going well for like that first practice test, and then it dropped again. And I think that was where it was like overthinking stuff. And it's like, okay, now it's like at least back up to where that initial spike was around like 120, 121. Um, but we want to like make sure that we take space from it so that we don't get that like overthinking,
Yeah.
over analyzing again, and just like, yeah, see what,
That's
like, you've done so much cars practice, just kind of like reset yourself and see where you
right.
end up.
See, talking about that makes me think then, what if we do a section, or what if we, as in me, but you know what I mean? As in, like, so we don't want to pay attention as much with cars. What about we minimize it? I mean, I know it's kind of crunch time, but
Hmm.
like every other day I do cars, but a section test.
Uh-huh. So like a whole 9
Yes.
passages dealio. Um,
I don't know.
hmm. I'm
Again,
like trying to,
I know we're like shy of 2 weeks, so it's really,
yeah. Because like what I think is at this point, like the cars, like you're pretty much solid on timing, right? Or like feeling better
yeah.
about timing. Um, it's like we don't really need it for timing, and we're not necessarily going to be super deeply like dissecting.
Mhm.
Um, um, but yeah, maybe just like because if you're going to be doing, I assume about like 2 section tests worth a day or something like that currently right now. So it could be like 2 sciences and then like science and cars and then 2 sciences kind of thing.
Yeah.
Um,
I mean, I have my little doodle thing. Yeah. So like that's what I have for now. I switched it off around based on my migraine days. So
mhm,
it's kind of dense towards the end of this week, but looking at the number of questions, it's not too bad, but that's also fulfilling in QPACs and section banks because I want to at least review some of the section bank questions before the scored.
mhm. Yeah, I think that would be a good idea. Um, okay. Yeah, let's say like I think either a full test or like half a test. I think half a test would still be fine, like 4 passages every other day. Like still keeping up fairly regularly, not
Mm.
necessarily going to be like it can be a little bit more compact, just to like keep like maintain the skill basically.
Right.
Um, I think like that's where I would land.
Okay. I mean, we could also switch that within the last week. I just,
Hmm.
there's also like question of, is it worth pushing the exam? Is it worth not? Then it's like, well, how much would I want to push the exam? And then the question is, well, what would I be doing differently now versus if I move the date? And I don't really know. Like, it's so hard to give that like pros and cons benefit. And
Hmm.
I don't know.
Yeah, no, that's like a hard place to be in. Just thinking, like, I wouldn't at this point, like, you've got the momentum, you've got the time off of work. Like, I
Yeah.
would want to stick with it unless you take that like final exam and it goes just like totally off the rails kind of thing.
Hmm.
Um, because I think that that's a helpful, like, it's helpful to have momentum and be prepared and be ready to go. Um,
Agreed. Yeah.
So, like, would lean towards taking it and just kind of going ahead as if you would, which you're doing anyways, and getting through questions. And then, next week will be kind of like that time to recollect and just prepare.
Yeah.
It's hard to say. Um,
Because a lot of it's really more of AAMC logic. At least that's what it is based on my Q packs and full length. Like it's all just
mhm,
logic. Little
mhm,
things like I already listed out based on the Q packs and the past two full lengths of where we have content gaps. And I'm gonna work on those throughout the next 2 weeks. Like
mhm,
I already have that and or week or so. So I already have like the content of where I think will help me be more like fill in those content gaps, but then also going through the questions will help me narrow down more of the wording. So
mhm.
I really don't know.
Yeah, and I feel like just having that, like, because it'll just be like 2 weeks of just like inundation.
Basically.
Um,
Yeah.
like I feel like that will just hopefully just like permeate your brain and like you'll just be in that headset.
Yeah.
Um, and just kind of like go from there.
Yeah.
Okay. So yeah, plug ahead. We'll see how this week goes and how everything's feeling. But yeah, I would definitely keep your momentum going and keep everything up.
Hmm. Okay. And what did you say about the cars again? You said to me, see if to do it every other day by half the test or like
Yeah, it's like half a test every other day.
maybe.
So yeah, so like take what would it be like 45 minutes?
Yeah.
Well, I would go either like 40 or 50 and do like 4 or 5 passages, and then um, you know just leave that there. Review, note what went right, what went wrong, but I wouldn't agonize over it or
Yeah.
spend like way too much brain power. Just um, kind of assess what's happening there, and then wrap that up, move on.
Okay.
Okay. Yeah, the final stretch. I have hope.
Apparently everybody does except me.
Well, it's easiest to be pessimistic like about yourself. So,
I'm like the worst critic. I'm such a pessimist. That was my nickname for my teachers in high school. Is I'm just such a pessimist. It's terrible. It's a bad habit.
yeah.
I need to break it.
Yeah. Oh, and I'm also like that in that like I was like getting out of the test and like counting on my fingers how many I thought I like might have even gotten wrong and
Yes.
like determining what my minimum score was gonna like I was so bad. And I just needed to like take a break and stop thinking about the test.
Yeah.
Um
I mean, I literally the
like
past month and a half, I've been having therapy every week, so I can keep some sanity and not be so just at myself. And so
mhm,
it's gonna be the next upcoming week's gonna be the longest. I won't see her because I'm seeing her next Tuesday and I saw her on Friday. So I'm like, well, let's
mhm.
see how this next week goes.
Yeah, will be maybe needed. I
Honestly, yeah.
feel that too.
So,
Yeah.
fine.
I mean, whatever works best for you to get um
In
like
that
in your right headspace. So
basically. Yep, yep,
yeah,
yep.
it's always my hardest thing to like give advice about. Is it's just like you know, I just
Mhm.
I just work better with stress. Like that's my own advice. And it's like not like it can. That's not necessarily very helpful because it could be
No, but
detrimental.
yeah,
Yeah. So it is what it is.
it does. But
Okay.
feel free if you think something needs to be pushed around or switched off. I try to maintain at 150, questions per day, which I think is truly doable. And Tuesday just or Thursday looks a lot, but that's just because I'm finishing up the section bank and they're both 40 questions since it's 100 questions per section. Um,
Mhm.
so
Yeah, no, I like your plans. I think you have a good outline. Yeah, you can just text me if you aren't sure what to do.
Hmm.
Yeah. I mean, at this point, it's like pretty straightforward. It's just like, just do questions, as many as you can, basically.
Yep.
Um, yeah. And then, um, no, so I know you still have enough hours left for today, but I think if you wanted to meet another time, you might need to have more hours for tutoring.
That's fine.
Um, I would just either talk to Joe or just let me know. But if you want to do something like next week, start of next week, to kind of like wrap it all up and just some final like I don't know, review and kind of question analysis and stuff, then um, just like put that on your radar.
Okay.
Okay, cool, cool. Let's get, I got the UWorld questions up and then the AAMC that you had sent me.
Hmm.
Okay. I think this one was the UWorld one.
Yeah, I when I was
Oh,
review, it's such a complicated, like, I don't know if they're ever gonna be so complex about like this is what it is, but just more of wondering what would be your approach.
mm-hmm. Yeah, yeah, definitely on first glance, it's like, because numbers, letters.
Yeah.
Um, the first thing that I am just kind of looking at is like thinking about what each of these things actually represents. So knowing that like this guy is going to be compound one,
Hmm.
and then this is the first reagent that we're adding up here,
Hmm.
and then we're doing it in water, makes sense. And then this would be compound two,
Hmm.
and then it has reacted with this reagent to oxidize it. It's added oxygen to this, and then other byproducts that seem to be left over potentially. um, so like I guess the first thing that I would just be looking at is like what atoms are being transferred where, because I think that's going to be like the first big change. And clearly it's that you have O2 here and O2 here, oops, that end up being replaced by hydrogens. So obviously those oxygens there have to go somewhere
Hmm.
because this becomes now hydrogens. And then obviously we have to get our hydrogen from somewhere. Um, and so just looking at what that would be, or what byproducts would come out of that. From the equation, we see a lot of OH. It's likely that we're getting our hydrogens from that water, which
Hmm.
makes sense why we have water as a reactant and then OH as a product.
Hmm.
So just identifying where is the oxygen moving, and then we're being replaced with hydrogen. So really just keeping track of what's happening with the oxygen. Um, and it looks like from the kind of breakdown here, it's becoming S2O3, which
Hmm.
kind of makes sense with all each of these. Um, so like the rough outline makes sense to me. I'm kind of immediately eliminating this guy because I know that this should kind of ionize, because we know NH4 ammonium is going to become like an ion.
Yeah.
Um, and so like I guess it's not really representative of what's going to be happening, and it doesn't make sense that we would draw the hydrogen off of the NH4. We would probably rather draw hydrogen off of OH because that's the solvent that we're working in, and we know that we have like a base present for this reaction. So like I think A overall like makes the least sense and is definitely like odd one out. And then B, C, and D are all pretty similar, just have different coefficients for the pretty much, yeah, have different coefficients, except for, I'm trying to see what the differences is. 2, 2, 5, One, one. Okay, yeah, same coefficients, but again, this has the NH4 ammonium ion included in the equation. And we know that that should be pretty much dissociated as an ion, and it would cancel out because nothing's really happening with it. So we wouldn't want to include NH4 in our equation, which gets us down to B and or C and D, which is it, like the one that you picked and then the one that was correct. I feel like the best way that I would look at this is to pay attention to, so this coefficient, because these oxygens, and then thinking about this sulfur because that's where the oxygen is transferring, and just kind of counting and balancing out from there. So this, as it stands, is 4 oxygens in one kind of compound. So we would expect to see 4 oxygens on the other side. Neglecting this because that's just from the water, so we can kind of just ignore the rest of it. But we now see that O has a subscript of 3. So there's no nice way to get to that point unless you're able to multiply them by something, and basically see what happens from there. So let's see. This is 2 times 2. Yeah. So this is going to be 9 oxygens. 3 times 3. Oh, well, let me just ignore that first. I'll put this is 3 oxygens in this base compound and then 4 oxygens in this base compound. So I would generally just kind of multiply them by the corresponding coefficient. So I would probably put this as like 3, and then this is 4. Trying to see exactly how this, the number of atoms in the and 2. Okay, some oxygen's got to go somewhere. Sorry, I don't know if there's a nice way to approach this.
They did the half reaction, so they did based on sulfur that was given in the first paragraph, the last sentence, that it will go from the sulfur ion to this 203, and then that gives an oxidation number of +2, and then also gives the oxidation number of N in the question stem. But I don't understand. I understand, okay, so you're basically going from a half reaction and trying to match that up. Okay. But the way that they were balancing those half reactions, I was like, why?
Okay. So it makes sense to me. What they said here was that this compound and this compound have to have the same coefficient. That would make sense because they're the same thing. It's just like you've swapped out the H's for the O's. And then yeah, this one's talking about the spectator ions. I guess what it's not. This would be 6, 6. And then this would be 8. And that would be 9. And so I'm just confused as to how they balance the oxygens. Let's see. Because this is 2, 4.
8
times 2 is 8.
7,
And then
9, 6. I mean, that'll be 15.
oh,
15,
this would be 9.
15.
Okay, so they used one oxygen from the water as well. Okay, because that's where I ended up getting tripped up because I was just looking at the oxygens here and then here,
Mm-hmm.
but they used an oxygen from the water as well because they started with 7 and they ended with 6.
Mm-hmm. I see.
So basically, okay, I would start there. You need these two compounds to be equal, so both C and D would be correct.
Mm-hmm.
And then we know that sulfur has to stay the same across both sides. So this would be 2, and then this would be 2. So that's correct. And then this is 6, and then this is 6. So that's correct. And then if you count your O's, that should balance out as well. Let's see. As we said, this was going to be 8
Mm-hmm.
plus 7, and then this is going to be 9 plus 6. And then up here is 4 plus 5, and then 3 plus 6. Okay, so both of these look like they are balanced in terms of atoms. Well, let's look at the H's because that's the last one. 10 H's, 14 H's, and then 4, 8,
6.
6,
6.
6. So yeah, H is all balanced too. So yeah, basically this is saying that these have the same atoms, like that atoms balance on both sides. So either of these would be correct in terms of like just balancing the atoms, which is why they then turned to the
Sure.
redox reaction to talk about like which one's going to be like which one's balancing the actual like redox that's happening.
Mm-hmm.
So I would generally just like pick. So like sulfur is a good example here. We know that sulfur S2 minus is now becoming part of this compound. So it's going from S2 minus to now over here S4 plus. Right? Is that right? S3.
Yeah, because 2 would our oxygen would
Or
be
sorry,
minus
2.
2. Well, altogether it would be 4 plus. Yeah,
Uh-huh.
2 of them. Yeah.
Yeah, because we have 2 sulfurs there. So one sulfur is going to gain 4 or going to lose 4 electrons. In this equation. So then we need to look at what else would be being oxidized to balance that out. And we're going to multiply this by 2 because there's 2 sulfurs. So I'm just going to say this is a 1/2 reaction with 8 electrons being lost. And now we got to check the other half reaction and see if 8 electrons are being gained. So I'll change color. That's going to be our NO2. Oops, I don't want to do that. Let's see.
It works.
Oh, close enough. So then what is our other half reaction? What is gaining electrons?
Your nitrogen, because it's gaining the hydrogens and losing the oxygens, so it's being reduced.
Mm-hmm. So we need to see that. Let's draw this out like this. This is generally what NO2 looks like, right? Because we also have this, so one's 4 bonds here. We are losing, or we are gaining, because right now in this half, oxygen is controlling both of these, right?
Mm-hmm.
So we should be gaining, let me just draw this out, sorry. 1, 2, 4 electrons because we previously didn't have control. Well, what's this pair? So 6 electrons because these were previously all under the control of oxygen. 1, 2, 3, 4, 5, 6. And now they're under the control of nitrogen, which is more electronegative. So 1, 2, and then the lone pair, 5, 6. So 6 electrons are being gained by nitrogen. Do you understand how I got that number?
Because they're more electronegative, they're going to be more in control of wanting those electrons. But then nitrogen is in control because it's more electronegative.
Mm-hmm. Yeah. So it's like basically like before this was the electrons that nitrogen had control over. And so it was like very oxidized because oxygen was pulling away the electrons. And then it gained those electrons because now this is what nitrogen is having control over because those hydrogens are clearly not going to be pulling those electrons far away. So he gained control of 6 electrons. And then we know that this coefficient is 1. So that's 6 to 6. And we know that that does not match up with our 8 electrons from the other one. So this does not balance out in terms of electrons sent and then electrons gained. But if we look down at this one,
Okay.
let's see if we can sketch it out. We said this would be 6 times 2. So this is going to be 12 electrons. And then we knew that this was also 4.
It's losing 4, but there's 3 of them.
Mm-hmm.
There's 12.
So this one does balance out in terms of where the electrons are flowing to. Makes sense.
Yeah.
Yeah, that one's like annoying because I feel like it takes a long time to like actually break down what's going on.
Yeah.
I definitely would have spent a lot of time trying to like balance the atoms just to find out that like both of these have the atoms balanced.
Yeah.
So I don't know. I don't love this question.
Yeah.
I think it's slightly more complicated than you might see on an AAMC exam, but not like you could get something similar in that you have to balance your electron flow, but I don't think it would be as like hopefully as involved as this.
Yeah. I mean, I did this as a section test, so I knew if I spent more time to really ham it down and get to an answer, it was going to cost me time for other questions. So I tried what I can with the time, and then I was like, screw it, this looks right, and moved on. But yeah, I agree. I don't think there wouldn't be anything complicated, but of course they're going to test the same line of logic of balancing equations, just probably a simpler way, a simple
Yeah.
equation.
What they also mentioned was balancing charge too. So that might have been the shorter way to do that because
I don't
you're
see.
basically balancing charge by balancing electrons, but that takes a little more time to draw
Right.
out. But they're basically saying that this would be minus 12, right? And then this is going to be minus 6 and
Oh,
minus 6. And then this is minus 4.
and that
And
would
then
be
this is minus 2, minus 6. I think that would be the faster way to determine. But you still would have to go through, double check your atoms, like make sure the equation's balanced and everything.
yeah.
So that might be the like shortcut version is to look at charge, but electrons will hold up as well. So I think it'll just depend on like what they're at. Like there might be 0 charge species, and they might be actually asking you to balance electrons. But yeah, that's the like shortcut way is to just balance charges.
All right.
And then just be aware of like for this one, it was
Spectator.
the spectator ions. Because I believe this is the exact same as this. It just has spectator ions present. So it would be, which makes sense why everyone was like evenly split between B, C, and D, as to what was actually going on.
Mm.
Okay. Cool. Overly complicated equation balancing. They love that stuff.
Yeah.
Okay. And then I have the questions from this one.
I need to remember what I wrote. Like,
Okay, 22. Yes, question 22. Okay. So this one I think is like pseudo, just like we'll glance through the passage again and kind of map that out because I think that'll be helpful to actually understanding what's going on. Cool. So we're talking about muscles. We have our introduction. MyoD1 is a member of the family helix loop helix, blah, 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 binding to CDKN1A. So I'll start kind of sketching out what I think. MyoD1. This is CDKN1A. Leads to differentiation. Okay, MyoD1 contains AC. Okay, and that one translocates to the nucleus.
mhm.
Okay, in vitro biochemical stimulus environment. So they're testing it with this cyclic tension strain cell culture chamber and looking at tension strain on myogenic differentiation in the presence and absence of TNF alpha, which is a pro-inflammatory cytokine. I'll draw that out over here. TNF alpha, which is going to lead to TNF. It's going to bind to its receptor
Mhm.
and then lead to NOS and NO.
Mhm.
Okay. Cultured myoblast cells were subjected to this cell tension test, and then mRNA levels were measured in the presence or absence of TNF alpha and NAME, a competitive inhibitor of NOS activity. Here are the results. Cool. We'll kind of dissect that down. Which compound is predicted to mimic the effect of exercise in undifferentiated muscle cells in vivo? Okay, so basically looking for what is the effect of exercise, which I'm going to say is probably what they're talking about in terms of this CTS cell tensile strain in these muscle cells. So how do we mimic this in the cells? So first we got to know what we're mimicking, which would be this condition.
Mhm.
So we're looking for what can increase MyoD1 mRNA. We can kind of dissect from there because we're looking for something to mimic this. So we can look at a MyoD specific microRNA. Probably not because that's going to be inhibiting the mRNA and we want to increase our mRNA levels. So that's kind of what we're looking for. Then B, an activator of NOS expression.
Be opposite.
NOS is
It'll be opposite because it would decrease.
because
Yeah.
it would be influencing down here.
Yeah.
So let's connect our to um, pathways right here, because when we have TNF alpha, that's going to decrease MyoD1. But then we see that the exercise still increases it, like relatively.
Mm.
But then LNAME also is able to increase it from the baseline.
But
So if this was saying like so this tension could increase it, or this LANME, LNA, yeah, LNAME, we'll just call it that, can also
increase.
increase, which means that we want to basically inhibit this pathway as much as possible.
Mm-hmm.
Because we saw that inhibiting NOS increased it, so activating NOS is definitely not going to increase it, so we don't want that. Oops. So then we have a repressor of CDKN1A expression. So we know that that's going to be repressing this guy, so that would like repress this whole pathway that we're trying to activate here.
Mm-hmm.
So I think it makes sense why D would be the best choice, where it would antagonize this signaling and basically prevent this signaling and then allow for this pathway to be more activated.
Yeah, that makes sense. I think I thought for C that to repress the CDKN1A was because you want more of the undifferentiated versus differentiated. So
Mm-hmm.
that because CDKN1A would give that differentiation, then repressing it would make it more undifferentiated, but that's not, I don't
Mm-hmm.
think that's the line of logic really with um
Yeah, that's
cell
not like
differentiation.
exactly what they were asking for. Yeah, because the effects of exercise would induce differentiation, in fact. So it's saying, like, how would you mimic this effect? How would you actually activate MyoD1 to activate differentiation? Because that is what the effect of exercise actually does.
Mhm.
That makes
When-
sense how they worded that.
Whenever they say of the effective exercise, would you automatically assume that it would be always anaerobic?
Um, I mean, I think in this case, I wasn't necessarily concerned with that either way, because I knew that the experiment, the only thing that we really have to judge is like this table, right? And they're
Mhm.
doing this in culture. So I feel like that's going to largely be like fairly controlled for.
Okay.
So like, yeah, I think it would all have to be pretty. I mean, I don't know. I feel like it's like it'll it'll differentiate for you if it wants you to think about anaerobic versus aerobic, or it'll tell you something about timeline if it wants you to think about anaerobic versus aerobic.
Mhm.
Um, but basically, what I got from that was like the way that they're measuring this is by using this um, cyclic tensile strain. Like that's how they're mimicking exercise. That's the only way that they were able to
Um,
actually kind of measure anything in this experiment,
because okay. What,
right? Because
how did you know that they were wanting to mimic CTS?
so just kind of looking at like blah, 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 blah. They used like a biomechanical stimulus environment and investigated the effects of cyclic tensile strain. Um, I guess I just thought about like if they're putting strain on myoblast cells, that's like mimicking exercise.
Okay.
Um, I guess it's like the only like how I thought that they were like that would make sense that that's what they're doing by putting strain on the cells
I
is
understand, yeah.
like stimulating exercise.
Mm-hmm.
Um, so that's why I was able to look at this graph here and say like when they do put this strain on the cells, it leads to increased MOD1 and then
Mm-hmm.
increased differentiation. So because CTS leads to this, it's probably likely that other like mechanical stress like exercise where you're physically like moving an arm or something is also going to mimic like this same effect here.
I see. Because I didn't make that connection before, and I think that was even explained in the AAMC explanation too of that comparison.
Mm-hmm.
And I just
Yeah,
didn't
it's like a
get that.
weird, yeah, the researchers use CTX to stimulate exercise. Muscle cells respond to this biochemical stimulus. It's like weirdly implied, but not super discussed that like this is what they use to mimic exercise. But
Mhm.
then when the question stems asking you about like the effect of exercise, like there's really only one thing that seems like it could be comparable to exercise from this passage, and that would be like mechanical stimulation.
I
So
understand.
that's kind of where I made that leap.
Okay.
Uh, cool, cool. Let's go to question 30.
All the genetics is like even
Mm-hmm.
the few pack that I did, like one genetics passage, 4 or 5 questions, all of them wrong. So I'm going through genetics. We're gonna do some Khan Academy tonight on genetics. Hopefully that'll help.
Yeah, hopefully that'll just give you the boost you need.
It's just this is where this is probably a really dumb question, but I don't know. But it's more like you can't assign the alleles to the Y chromosome. Yes. But then when it comes in to say asymptomatic man who is heterozygous for the cystic fibrosis allele, but then I don't understand how is that labeled on the chromosome if it's XY but it's hetero, but the Y is not containing the allele. Do you know what I mean?
Was this one a sex linked one?
Yes.
Just look at the, because I think it was more going to be like not sex linked. This is just autosomal because
Oh, so that's what.
if someone is heterozygous, like that means that they do have two alleles. So it's not like an X linked gene because there are two alleles. So this is just like a regular old, like autosomal, big A, little a kind of deal.
Oh,
So maybe that might be where the confusion kind of came into play.
okay. So if it's
Um,
like the homozygous, heterozygous, it doesn't have to be sex linked.
correct. So if a man is heterozygous,
Maybe we should do that cute pack
that,
question then.
yeah,
Okay, go ahead.
if it says someone is hetero or even homozygous, that implies that there are at least two, right? So
Yes.
obviously in the case of humans, it's going to be two, um, which means that they have to have, like, you can't be heterozygous if you just have one, like, you don't call it heterozygous if you just have, or homozygous if you just have one allele. Heterozygous means you have one allele one way, one allele the other way. Obviously, homozygous means you have two of the same allele, but you have to at least have two. Like there's a plural there. So if it
Yeah.
says homo or hetero, you know that there's two. And so if a man is homo or hetero, that implies that it is autosomal because it has to be on a chromosome that the man will have two of. So we can tell from here if a man is heterozygous, he has to contain, maybe they're both on chromosome 2, maybe they're both on chromosome 8, doesn't matter, but they have to have two copies somewhere. So that should set up like part 1, which is the man is heterozygous. And we know they're asymptomatic, so it's probably a recessive gene if they're able to be a carrier, heterozygous genome, but not actually have the disease. And
Yeah.
then we know the woman has cystic fibrosis. So we're going to put little a's, and then we can just go from there. What is the probability of the child having cystic fibrosis? Whoops. Well, we already said that you can be a carrier, like the dad is, and not have it. So it should just be these two kids that end up having cystic fibrosis.
Got it. Okay.
Does that make sense?
Yeah.
Mm-hmm. So that might just have been like kind of the terminology that they used. But yeah, I feel like if it was sex linked, you would have some kind of indication in the question stem in like men are much less affected by this disease, or a um all daughters with this have an affected father, or something
Yeah.
like that. Like they would have to allude that to you.
Yep.
Um, and in this case, they were alluding autosomal by using heterozygous.
Okay. Well, then maybe I can reason my way out with that QPAC question then after reviewing.
Mhm.
Okay. Which one was this one?
Yeah.
Oh, yeah. I
Okay.
didn't. What the wording? Yeah. I knew what was going
Mhm.
on. I was just like, okay, what?
Okay. We'll go back. I'll go back through and like quickly
Yeah.
just glance over the passage. We've got GABA. Feel like that should be familiar. Blah
Mhm.
blah blah blah. Um, so let's check this out as GABA. Then we've got chlorine into cells. The insecticide dieldrin acts as an inhibitor of the receptors, blah, 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 blah. Then we see that resistance has appeared. Untreated populations lack this resistance. So we know some kind of evolutionary change. And we've got a mutant form. RDL is resistant to dieldrin that has been cloned. So I'll draw this in as RDL resistant.
Yep.
Then we have frog oocytes. So we're starting just with like a cell that we're going to use. Transfected with cDNA encoding either wild type or RDL forms, are exposed to GABA with or without dieldrin. So we're thinking about our receptor. We're thinking about our GABA. And then we're thinking about whether or not the dieldrin can actually inhibit this.
Right.
And then they look at changes in cell membrane potential. Ooh, I see. I was like, what is this? Okay. So we see a big dip in potential when you do treat with GABA, which makes sense because we're letting a lot of negative chloride ions in, which then eventually levels out over time and increases back to baseline.
Mhm.
And then when you add the inhibitor, you don't get that big drop. So this is what inhibition looks like. And then this is what it looks like with our resistant form. So it's able to basically replicate the wild type and unaffected by dieldrin.
Mhm.
Cool. The RDL mutant has been mapped to a single base pair substitution of serine for alanine at amino acid 302. The same base pair substitution has been found in GABA receptor genes of dieldrin resistant strains of several insect species. So this is how they gain their resistance. Pretty straightforward. An alanine to a serine. Okay. Which procedure would be the best negative control for endogenous GABA receptor function in frog oocytes? So yeah, let's think about the wording and then experimental design here. So we're looking for a negative control
Mhm.
of the GABA receptor function. So we want to see some like baseline activity or something like what is it going to look like when you're not like what is a good negative control baseline for this function? I feel like the best way to do this is just read through the choices. So we have the addition of GABA to mock transfected frog oocytes. So that's going to give us this, where we see this big dip.
Mhm.
We have the transfection of wild type GABA receptor into insect oocytes, which is going to just show us what the wild type receptor looks like at baseline. We have addition of excess GABA to RDL transfected oocytes. So adding on to this condition, adding excess GABA.
Right.
Or transfection of wild type GABA receptor into RDL expressing oocytes. So we want to know basically, how does the GABA receptor function normally?
Mm-hmm.
This is a weird one. Transfection of wild type GABA receptor into RDL expressing oocytes. I believe you want to just kind of be looking for like, what is the baseline activity of GABA receptor?
Right. So like you just don't want any effects, just this normal
Mm-hmm.
cell, normal GABA, normal receptor.
Mm-hmm. So do you remember which one you picked on this one?
I think I did D
Okay.
because
So for
I knew for B I was more of, well, insect oocytes, that's a different, like it's an insect, we're in frogs. So I thought, no, that's gonna be different. In
okay, yeah, definitely.
addition of excess GABA, that's not going to help anyway. And also, we don't want RDL transfected because that's already talking about the mutant.
Mm-hmm.
I had no idea what it meant by mock transfected frog oocytes, but that's the answer. But I didn't
So
like what? Like it's the
okay,
wording for that.
okay. So basically, if so it says we'll have two conditions here that they've set up. One is where they've added wild type receptor, right?
Yeah.
And one is where they've added RDL receptor.
Hmm.
And we're going to then add on GABA and see what happens.
Correct.
However, we don't know what the GABA might be doing to these cells at baseline, right? So baseline, they have neither receptor. They have neither the wild type receptor transfected or the RDL. So what they're saying is we can add GABA at baseline and theoretically nothing should happen. But if
Oh,
something does happen, you have a like baseline reading of what went, like what was the activity, like with no other involvement from what we transfected in. So maybe there's like, let's say like 10% of the activity is just like actually like baseline GABA activity from the oocyte itself. You can figure that out, do this test, measure it. So then when you measure what it reacts to with the wild type receptor or how it reacts to the RDL receptor, you know, you can like take 10% of that away because that's just like the baseline activity. So it sets your bar of like, here's what zero activity looks like.
I thought the
So,
wild type receptor was baseline.
so the way they word it is that
Of
they're
course.
transfecting it with cDNA encoding wild type or RDL forms. So um, maybe these frogs don't naturally express this, or like, I don't know, whatever they're saying is happening, like they're adding in cDNA
Wow.
to express this and cDNA to express this. So
Okay.
that's why we want to do this, to find what that baseline is without either of the cDNA added. Like, what is GABA doing on its own in these cells?
Okay.
So when it's asking about our negative control, the best way to think about that is like, this was our baseline, right? This was where it either dipped from, this is where it like dipped away from and then came back to. So it's like, how are you going to measure what this baseline is? You should measure kind of basically what's happening in the cell without GABA, with
Mhm.
GABA, and like theoretically completely independent, so that you know that the dip that you do see is purely due to GABA's effect on these receptors and not to GABA's effect on anything else.
Okay.
Does that make sense?
Yeah.
So I agreed with how you eliminated B and C. I think what would have turned me away from D is just that then you'd just be expressing like both receptors. So I don't know how, like, it wouldn't really think of as like a negative control,
Mhm.
because we're expressing our mutant one, and we're not really looking for like what our baseline is. Like generally our negative control is going to either involve our wild type or just like baseline, or in this case it was neither, but it probably won't involve the RDL expression.
Then when it was saying about the mock transfected oocytes, is that just the cell that's being affected, not the receptor? So A is saying like the receptor is not present.
Yeah. So when you're adding the receptor, you can imagine it's cDNA. And because you're transfecting it in, it's coming in this nice little like package that's going to help it enter into the cell. Then the package can go away. Then you have that cDNA that can be expressed. So essentially, what you're doing is you're just sending in that empty package. So you're mocking what transfection like would look like, but you're not actually expressing any cDNA. So it's like when you add like DMSO or like some kind of like solvent, just like control for making sure that you're not like
Okay.
affecting the cell or anything by adding like the other stuff that you're not trying to measure.
So it's like you have an empty vector and a plasmid, basically.
Mm-hmm. Yeah,
Okay.
basically. So this would be like your empty vector version. And then this is going to be the plasmid. And you just want to make sure that that empty vector is not actually affecting anything or changing anything at all.
Okay. Okay.
Okay.
All right. Yeah. Yeah. Wording. All right. So same ideas, just the wording was
Mm-hmm.
off. Okay. I understand.
Yeah. And I guess just honing in on negative control, thinking about like the baseline. It's hard to tell what they're meaning by baseline, but in this case, at least, it's like when you have neither receptor present, that would be baseline. And then obviously, like condition one would be like wild type receptor, condition two is going to be mutant receptor, but they're each kind of judged off of a baseline.
I thought they were testing the receptor itself in the presence of GABA or dieldrin, not actually the receptor of itself. And GABA, we already, like GABA was just to show the effect of dieldrin and what would happen.
Mm-hmm. Okay. Another genetic.
Yep.
Now we do that in X and Y. White eyes are recessive to red eyes, and yellow bodies are recessive to dark bodies. Both genes are on the X chromosomes. The genotype of a red-eyed, dark-bodied female could be determined by mating it with a male that has which of the following properties. Okay, so let's draw out first what each is going to look like. So we have red eyes. We said are going to be dominant. So if you have red eyes, you could either have this phenotype or this phenotype.
Mhm.
And then white eyes, you would have this phenotype.
Mhm.
And then with yellow, well, let's start with actually dark. Dark bodies would have either this phenotype or
Little D.
yellow
Yeah.
would be little d.
I kept
Okay.
thinking blue flowers, red thorns, blue flowers, red thorns. It's going with
Mm-hmm. Yeah. Okay. So then we have this female,
Mhm.
and we're going to be mating her with a male. So this would be what it looks like for a female, right? Because they would have two X's. So, yeah, both these genes are on the X chromosome. This female could look like, could basically have any combination of these guys. I won't write them all out, but like just understanding that each of these is actually like on the X chromosome.
Yeah.
Okay. So this is what it would look like for a female. And then possible male genotypes I'll just scroll down here, would be
Individual.
either red or white or
dark green.
dark or yellow.
Less
So
options.
here are options. Yes. So definitely there can be more female genotypes because they have more physical alleles that could carry those genotypes.
Yeah.
So now we want to figure out what are we mating it with to just see genetically what it has. So if we know our females are red-eyed and dark, we're basically trying to test, is this a homozygous dominant or is this a heterozygous recessive? Or like heterozygous.
Yeah.
So if our female has both dominant genes, no matter what kind of male we mate her with,
It wouldn't matter.
she's going to have a red eyes because she has two dominant genes. She'll always have at least one. But if our female is heterozygous, we could mate her with a red male, or we could mate her with a white male. Now, if we mate her with a red male, you run into the same issue where everything is still going to have that one big R because the male has that one big R. So we want our male to have the recessive phenotype so that we can see if any of the kids have the recessive phenotype, the mom had to be heterozygous. If all the kids have the dominant phenotype, then the mom was homozygous.
Yeah.
So the only way that we can get this combination where we see a different color is if we are able to mate with a male that is recessive and has the little R. So we know that we're looking for white eyes because otherwise we'll have a big R in everything and everything will be red no matter what. It's not going to give us an answer. So same concept is going to apply to the body. We're looking for a way to differentiate if the mom is heterozygous or homozygous for this dominant trait. So we know if the male is dark-bodied and has that big D, then every child is going to be dark-bodied and it's not going to make a difference. We're not going to see any different phenotypes. So we're going to want to mate with a male that has a yellow body so that we can see, do our children look like this?
Or homo.
Or this? Yeah. Allowing us to see if that mom had that little D in the first place. Because this is the only one that'll physically be a different color. So does it make sense how you would pick the two male recessive genes?
So you would kind of have to work backwards more or less, or just like, I don't know, with exploring.
Like, I guess the shortcut way for this to say is that when you're trying to test phenotypes, you generally want to use a recessive. Like you generally want to mate with something recessive to see what's happening. Because if we're testing a phenotype, like in this case, we're trying to test what the female's phenotype is. Like we know she is dominant because like she has at least one of these dominant genes that is going to allow her to have that dark body. So like no matter what, we know the mom has a dominant allele. So we want to try to combine that with as many recessive alleles as possible to basically see, is this dominant allele here all the time? And is every child dominant? Or is there actually heterozygosity here? And in which case, 1 out of 4 kids, you would get that double recessive and then see a different color.
Got it.
So just in general, when you're testing for heterozygosity, you're normally going to mate with the recessive phenotype and then see if every child is still dominant, then it was a homozygous dominant. Or if you get a mix, then you know that they had a heterozygous um, genotype to begin with.
Okay.
So hopefully that makes sense in like a much faster way to actually get there.
I mean, both ways it works. Yeah, I understand both.
Yeah, it's like, how do we fill in that question mark? We're all, we already know that there's a big dominant allele. It's like, so the best way to test that is to combine it with recessive alleles and see if that's the case, like across the board or just 50% of the time.
I thought this was like going to be a 4x4 planet, so that's why I was like, oh,
No, thankfully not as complicated as that, because it's basically asking you like, how do you test that? It's like when it's an unknown, if it was asking you what the offspring were like, that's when you would have your square. But it's like, because this is an unknown, it's saying like, you want to generate a Punnett square. Like, what are the two things you're putting in? You want to put in, your thing that you're testing, and then your recessive genes, and then see what happens. So I'd say like pretty much, if it ever comes up in a question of like, how would you test for genotypes, or how would you test if someone is heterozygous or homozygous? Pretty much always the answer is going to be to mate with a recessive gene and see what happens.
makes sense.
Cool. I think that was everything from your review that you sent me.
Oh, I think there was one more. 30.
30. Was that the one that was the sex-linked one? Or the not sex? Yeah, the cystic fibrosis one.
Oh, was it? Never mind.
56. Did I do 56?
So why don't we do this? So I will.
Yes. Okay, I think we did everything. 56,
Maybe we did all of them. Never mind.
30, 22.
That one's
One,
fine.
two. Okay. Yes. Okay. Did you want to just run through a couple, like a passage worth of UWorld or something, just to go through some science strategy, or would you rather just do that on your own?
I mean, you want to go through the genetics on the Q pack?
Sure, that sounds like a good idea.
It's
See if we got any shortcuts.
the first Q pack, the bio, obviously. Questions 90 through 94.
Bio, QPAC 1. Let me reshare with you.
The lovely.
Question. Have you done them yet? Oh yeah.
They're all X's. They're all like, girl, you sure you know your genetics? I'm like, nope. I don't.
Yeah. Old.
Yeah, I don't like that we don't have that option. It's like you have to first review it and then go through it.
Yeah, I think that's just like a slight glitch of this add-on. Honestly. Okay.
Who is this guy? Can you type the name in the chat?
Okay. 90 is where it starts. Okay, awesome. We've got several species of Drosophila have X-linked E and F genes that affect the sex ratio of individuals' offspring. However, the genes only affect X sex ratios if they are brought close together by an inversion of one arm of the X chromosome. So here's our picture, EAF, inversion. This is the case where it would affect sex. An XSY male is standard. He sires equal numbers of sons and daughters. An XI male expresses, okay, so this is standard, equal number of sons and daughters. Sons equals daughters. only daughters for these XI males. Total reproductive output is not affected. They sire the same number of offspring. Okay. If none of the XI bearing genotypes is selected against, then the frequency of XI is expected to increase to 100% unless other genes act to suppress the frequency of E and F. So this is saying like basically it would end up becoming dominant, and we would have the frequency, a high frequency of XI, which would be bad because then we would only have women and then the population would die out. So it seems that like we want to potentially select against XI to prevent that from happening.
Because there will just
Occasionally, because otherwise, like if when this reproduces, like there's a 50% chance, like, or you're gonna, like if this person reproduces, there's a 50% chance that their child can then only have daughters. And so like essentially 50% of their offspring can then only have daughters, which means that like you're kind of slowly funneling away the proportion of the population that can have sons. And then you'll be left with no one that's able to have sons.
I see.
Because it looks like SI is either dominant or, just like slightly beneficial or like something, unless you select against it. Okay. Occasionally, XI males sire viable but sterile sons of normal appearance. Genetic analysis shows that these sons are XO, inheriting their X chromosome from their mother and lacking a Y chromosome. Okay. I don't know if this was one of the ones you got wrong or right, but we'll start here.
None of them.
Okay. If all genotypes are equally fit and there are no genetic modifiers of the sex ratio trait, what will be the ultimate fate of a population in which 50% of the X chromosomes are currently XI and 50% are XS? And then XS is 50%. So this is saying there's no fitness advantage. There are no genetic modifiers of this trait. What's going to happen? We know from the passage that if none of these genotypes are selected against, then you would get the XI ratio to 100. So I think this would be that case, right? There's no different advantage in survival. There's no selection genetically against it. So you expect to see that XI increases to 100. In that case,
we all of them will be daughters.
Yeah, you're basically only ever able to have these guys. There would be no males. And then you would expect that pretty much everything would die because you would no longer be able to reproduce. So that's what it's saying, that like if the frequency is increasing to 100%, they're going to end up extinct. So this is just like from this paragraph here where they do that.
Okay.
Okay. Okay. In a laboratory population of Drosophila, all males are XSY. Assuming the females are these things, what proportion of male flies in the next generation will be XIY? Okay, so this is like a statistics type problem. So what I'll do, I think the best way to do this would be to draw out the 3 different scenarios that can happen, where we have XI, 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 XS, XS, XS.
That's what I thought too.
Okay. And then this is going to be X, S, Y. So let's go from there. We're just looking for male flies. So I'm just going to draw out the male flies.
One, excess Y, excess Y, excess Y. So be 3 out of 12, 1/4. Yes.
So then the way that I would do this is I would say, so let's just pretend it's out of 100. This is going to be 15% of the offspring. This is going to be 50% of the offspring. And this is going to be 35% of the offspring. So we can scale them up appropriately based on that. So if 15% of, this is saying that 15% of the males, pretty much 15 out of 15 here are going to have this trait, right?
Mm-hmm.
So I'll say that is 15 out of 15 plus, then we'll say 25 out of 50 are going to have it in this case. And then I'm going to say,
0.
yeah, 0 out of 35 are going to have it in that case. So then just doing the math here, I don't know if there's an easy common factor, common multiple. 4, 5. Actually, you could divide that.
150.
Yeah, it's probably the easiest way to do that. So 150 out of 150.
Plus 250 over 150. So 3 or 400 over 150.
Or what did you do for this one here? Because this should just be times
10.
15 or times
3.
because it's,
Sorry.
yes.
I thought times 10. I'm like, no, wrong girl. No. So then it should be 75. Sorry, not 250. That makes the math better. So it'll be 125.
So what ESMA, I think what ESMA tries to
150.
provide you is some
It would be
anecdotal
D.
evidence
It's over
that
50%.
there is migration. But I think the
15.
empirical issue really
5,
is
12 down, 21, 225. And then it's going to be like out of 300.
Yeah. Oh, I can't do math. Yeah. 225.
Well, because technically that when you're adding fractions, that's not right. But yes,
Yeah.
I can show you.
because this is like a 1.
Mm-hmm.
Hold. See what they say. C, B. Okay.
You just look at math.
Got it. I think maybe. Let's revisit this. Maybe that wasn't the best way to set it up as a fraction. This is saying like, okay, I'll set it up like this. So like 0.15% of the females are going to produce 100% of those offspring.
Mm-hmm.
Yeah, this will be better. And then 0.5 of the females will produce 0.5% offspring. Okay, there we go. So it should be 0.25 plus 0.15.
Which gives you 0.4.
Yeah, there we go. Okay, so percentage times percentage of the males, so 15 times 100%, and then 50%, 0.5 times 50%. Okay, there we go. So basically looking at the percentage of the percentage. So hopefully that makes sense why that works.
Yeah, I did it like out of the entirety. So I thought of 12 rather than out of 100 because there were 12 options due to the 3 squares. And I kept getting 25%. And Okay, rounding up to 30.
Yeah. So that would be if these were all in equal proportions then, but it's saying like if one Punnett square is weighted more than the other, because more females are going to be end up being this phenotype than that are this phenotype.
But like you said, it's the percentage of that because all of them are going to be XIY for XII, and then one of the two will be XIY, and then nothing will be from XXS or the last.
Yeah. So this is like percent times percent. And then just add them up. So this is like percent of the total. And then this is like percent of that portion. Does
Yeah.
that make sense? Yeah. There we go. Don't try to do fractions is what we learned.
Want it to be 1, 2, and 3. 1 indicates that the space. 2 indicates that the
Oh. You know what's silly? I think if we'd just done it as like 15 out of 15 plus 25 out of 50 and then just added them, it would have worked.
that we survey
Would it have?
is actually located in a region where
40 out of 65.
Oh, and you would have needed to add.
there might be some other
I see. Yeah, you could have added it like this, where you did 15 out of 15 plus 25 out of 50 plus 0 out of 35, because this is going to equal 100 on the bottom. And then you should just get 40. So, but that's technically not like how you would write fractions. It's the same thing we just did, but same idea.
I understand. Yeah.
Okay. Which of the following statements best explains why XI has the potential to increase to 100% frequency in gene pools that contain it? So how would XI become the completely dominant genotype? So we know that whatever answer it is would have to favor XI homozygous genes.
Right.
If we're looking at A, it can't be A because we know it's not going to favor at all the heterozygous genes, or we would retain some of that excess. So we should be able to cross out A. Okay. B, flies tend to migrate and introduce the chromosome into new populations. That's not necessarily telling us why it has 100%, why would it increase to 100% frequency. That's just telling us how it would spread between populations. And we're kind of looking within one gene pool. I feel like this one doesn't necessarily make sense to answer, like why once it's in a population would it increase all the way to 100%.
So we are talking about one gene pool, otherwise it was specified.
Yeah, that one's just kind of about like migration, and we just say that basically like here's how it could be introduced to a new population, but it doesn't explain why when it's introduced it becomes like 100% of the population. Okay. XI flies past X chromosome to all their offspring, but XS flies past their X chromosomes to only pass their offspring. So let's draw out what that would look like. XI flies are obviously going to give every child one of the two. So that would make sense in that, yeah, that's 100% of your X chromosomes. Like you have to give one to each, and they would pass their X chromosome to their offspring. But XS flies past their X chromosomes to only half their offspring. That wouldn't necessarily make sense to me because each offspring still has to contain at least one X chromosome that came from mom. Like no matter what the genotype of the mom is, it's going to be passing one of these alleles on. So I'm gonna kind of.
No, it's clicking. Keep going. You're good.
So I'm gonna put a pause on C, but I don't like that because it's like it still has to pass its X on. So the mom always has to pass an X allele on, but the dad doesn't have to. because the dad can also have sons and pass its Y on instead. However, these XI flies can only produce daughters, and daughters need one X from mom, one X from dad. So that means that in every case where the male has an XI, the daughter has to get an XI.
Right.
Because it has to give this XI allele to its daughter.
Yes.
Versus in the case of males, it could give either this to its daughter or this to its son. So males don't always pass along their X chromosome. And so in this case, males are forced to pass along their X chromosome, and this would have to like basically perpetuate. But in this case, they don't have to, and you can still get Y, and it's not necessarily like forcibly passing an X chromosome.
So it does pass half of their offspring. It's just, oh, but it doesn't have to mean X exactly. It could be X or Y.
Mm-hmm. So yeah, X, like if they just have 50% daughters, 50% sons, 50% are getting an X from the dad, 50% are getting a Y from the dad. So only half the offspring are ever actually getting dad's X chromosome. Make sense?
Yes.
So females always pass on their X's, like undeniably,
Yeah.
because it's like your two choices are, like for females, it's one choice and it's which X are you passing on, but it's still 100% of the time is an X. And then for males, that's when you actually have a choice between X or not. Okay.
Then what was their reasoning for C? Why was the second portion incorrect? Oh, it's just saying,
So
yeah, just
only half their offspring would get X chromosomes.
which is
We know
false.
that every offspring gets, like 100% of offspring would get an X chromosome, because every offspring, regardless of sex, would get an X chromosome from mom.
I see. Okay.
So on a case like this, it's basically moms always pass an X chromosome, dads alternate between passing an X chromosome or a Y chromosome, unless in this case it was talking about how men could only have daughters, which they'd be forced to pass the X chromosome, which is why you would see this allele gaining so much like potency in the population. Okay. A virgin female Drosophila mates and produces 34 sons and 38 daughters. 18 of these sons sire only daughters, while the remainder sire approximately equal numbers of daughters and sons. What are the genotypes of the original female and the male with whom she mated? Okay. So to start off, we know we have a parent generation where we'll draw a mother, next forward, and we get 34 plus 38 kids, 72 kids, which are a mix of sons and daughters. And they're asking us for the original like mother father genotype. So we know right off the bat it can't be this for the dad because they had a mix of sons and daughters. So we know the dad has to have had a normal allele and should then have been able to reproduce both sons and daughters. So it's not B or D. So in this case, then we're kind of left with figuring out what would happen. What do these percentages tell us? So 18% of their, or 18 of their sons sire only daughters. They have 38 sons. If 18 of them are going to be this genotype, it looks like, so that's about 50. Right?
Yeah.
So they ended up with about 50% of their sons with this genotype. So we would expect it to look probably like somewhat like this for their sons. 50% were able to reproduce normally, 50% only sired daughters. So this would probably be what the son's genotype look like.
They're half and half. That's the same. Okay.
Mm-hmm. So then deducing from there, we know they got their Y from dad, and we already knew that dad was normal. So that means that they got their X's from mom, and they got one normal, one affected, which would bring us to A.
The third best would be, and I'm not saying that's like a lot worse necessarily, but the next best.
That makes sense.
Yeah.
You know, a place where a lot of
This is just kind of like deducing backwards. And it was helpful where like you could have also approached this from the other way where you just sketched out what would this look like versus what would this look like. But in this case, like we know at least some of the sons were normal, which means that the mom had to be heterozygous because the mom's controlling all the sons. Because the dad is unimportant for sons, basically.
Yeah.
Okay. That's going to be the best way to deduce that backwards. Or if you just wanted to, you could pretty much eliminate these and then guess and check with AAMC, which one like would make more sense.
Then otherwise, if XIY was from the dad, there can't be 38 sons, right? It would all end up being daughters, no matter what.
Correct. Because they would only ever be able to have daughters.
Daughters, period. Yeah. So it wouldn't even matter for the mom to be hetero, because it wouldn't. Well, I don't know.
Yeah.
By excess,
Like,
I don't know.
Because like you could be like this for the mom and this for the dad and still produce only daughters.
Yeah.
That's all going to depend. So the sex determination is basically saying like normally we assume that it's like 25% would be this quadrant, 25%, 25%, 25%, versus this is telling us that when you have this allele, it actually changes this ratio and it would make it like 50-50, 0-0. So basically not to confuse the only having daughters with the actual genotype, like it's still like a random distribution. It's just like somehow, I don't know, inhibiting the transfer of the Y or like preferring the transfer of X over Y. Like we don't know exactly what this mechanism is here. We just know that it alters the sex ratio. So that's what it was talking about with the sex ratio trait is like 25 to 25 to 50 to 50 kind of thing.
Because this is standard, the one you have to the left, that's standard what you're expected, but because it's inverted and it's altering that sex ratio state in the passage, it's 50-50 and the males aren't even present.
Correct. Or occasionally it says they're like X0, so it's like because it gets rid of the Y chromosome. So like for all intents and purposes 50-50 of daughters, but like the occasional like random sterile son that's just an X. And in that case, you can like something went wrong kind of thing.
And that's only if E and F are not suppressed. If they're suppressed, then it would be altered.
Correct.
Okay.
If they're suppressed, it could be normal, which is why it's saying like, you know, this is standard, this is what you want. When you bring them close together, you get this abnormal unless there's some kind of genetic suppression here.
Okay.
Is that okay? One more. Okay, if the E and F genes are expressed, the XI chromosome will be prevented from reaching 100% frequency if selection pressures cause which of the following to be true. So we're looking at selection pressures. If they're expressed, what's going to prevent this from taking over? So we already mapped out how it would take over because the males would be forced to pass on the XI trait. But it's asking like what would prevent this from becoming the most 100% frequency. So the best way to do that would just be if this XI ended up having something that was like bad or selected against, something that would hurt in its viability so that that trait wouldn't be passed on, so that the offspring with that trait would die more often and the healthy trait would be more passed on. So I think just on first glance, this would be like my
It makes
favorite
sense.
answer.
Yeah.
Because you'd want to select for the normal gene, the healthy gene, and then that would mean that ones that have the XI are just less likely to survive and then less likely to pass that on. We don't want these to have equal fitness because that means then that males either like that are like they're gonna be able to pass them on just as frequently as the normal genes. This is like the opposite.
Yeah.
And then kind of similar for females, we basically don't want to introduce any advantage or even just like neutral with XI. We want it to be heavily favoring the normal version. Okay. Does that make sense?
Like, let's say.
Then when it says for low versus high fitness,
You know, it'd be really nice to
why
observe
would it? Well, it makes
those
sense why it
people
would
and
be
see what
high
they look like,
fitness,
right?
why you would need one
So
higher
if you see,
versus
for
low.
example, that,
Mhm.
you know,
But
people
Yeah.
of almost certain income migrate to the state.
Basically, like you'd want that to be most favored, and even if a female had something like XI, like this phenotype, you'd still want that to be somewhat selected against because you don't want that male to get that chromosome. Because what happens is when they get this phenotype, that's when you're forced to pass on the X, and that really allows it to penetrate into the population. So you want to select for people with the solely healthy phenotype and then allow for, yeah.
no, I was just gonna say, like, could an alternate answer be that XIY has a lower fitness than XSY or XIXS is lower than XSS? Not that they're equal.
Yes.
Okay.
Yes. That could be one. Yeah, that like kind of the opposite of this, where this is more fit. That could be helpful. Or yeah, like you said, where this is more fit. Anything that's gonna allow you to like help select against this gene is gonna be what's helpful. So it's also just saying like this would then be the best. So it's kind of like included in that where like, oh, it's more fit than the XI version.
And just a clarification, we were never stated that the inverted was a dominant, right? Like there was no dominant versus recessive. It's just their behavior.
Correct. The only thing we know is that it has effects in males where it's the only chromosome. Like, because here, like, we don't know what the difference between this female versus this female is.
Yeah.
Honestly, it just seems like she's a carrier because it doesn't affect sex ratios at all. So it's neither dominant nor recessive there. It just is because the females aren't involved in the sex determination. It only matters who has it in the male or which allele they have in the male because that's the one that's actually determining the sex.
Potentially missing.
Okay, that actually helps a lot. Okay, cool.
So it doesn't necessarily have to be dominant or recessive. It might just be, like in this case, it's like it doesn't matter. Like it's only a gene that matters for males. So it's not going to be dominant or recessive because it's just in males and there's only one allele. So it's just like a yes or no rather than a dominant or recessive.
But it's still sex linked, not autosomal. Okay.
Correct, because it's on the X chromosome.
Yeah. Okay, that helps a lot actually. But you
Yeah, this
can't.
one's like a.
Sorry, go ahead.
I was just going to say this one's like a more complicated version of it. This is definitely one of the more complicated genetics passages.
But like the logic behind it makes sense, which is what I find more beneficial. I think complexity, whatever, but it's just more of the concept followed through.
Yeah. I think what they didn't want you to mix up and where it gets tricky is like you have to kind of chart out what the potential genotypes would look like. And you can't confuse like, oh, normally 25, 25, 25, 25. You can't confuse that with like the 50 versus 0. Just to like understand like, okay, females are still going to reproduce. Here's like still our normal Punnett square. But just to remember that like XI males can only produce females. So that like skews how you would normally draw out your Punnett square because you're leaving out 2 squares that you would normally draw.
Mm-hmm. Okay, that makes sense. Cool.
So cool. Okay. I think that's it for that one.
I might even have more
Uh,
genetics on UWorld, so that could also be interpreted after Khan Academy.
Yeah, that could be helpful to do, just like get some practice with that. But yeah, I feel like that's the extent of the most complicated type genetics questions you would get.
Mhm.
So if those start to make sense, hopefully most of it should make sense.
And also applying correctly Hardy-Weinberg, which makes sense. It's just more of correctly filling in what the
Mhm.
numbers are representing. But
Yeah,
I don't have problems with those. If anything, it was
yeah,
just the math, but the
yeah,
concept behind those are fine.
yeah. And like Hardy-Weinberg sort of would relate into, I mean, it's different because Hardy-Weinberg is obviously when you're at like a genetic like equilibrium.
Yeah.
So we're talking in this question about like how the I could increase all the way to 100%. Like that would be a population that's not at equilibrium because the genotype like percentages are still changing.
And it's independent because it's more of, it works on itself based on the other factors.
Mhm. Yeah, and that's not, like it's not being, or like the way they set it up in the passage was like if it was not being selected for or against, like this would just take over, and that's just like math.
Mhm.
And then it's like, okay, you need some kind of survival or fitness hit for this to not take over. So that's where the like rest of the multiple choice questions came in.
Yep. Khan Academy, be my savior.
Yeah. Well, I mean, there should be still a few more UWorld questions too, and then um, you can glance back over this one, but like it's honestly, it'll just be like a 50-50 whether or not you get like a pure genetics passage like that on your exam or not.
Right.
It's like it'll definitely come up and stuff, but like it depends on whether or not you get like a whole passage that's like XY Punnett squared, like that kind of thing.
Like pedigrees, like before, just all that jazz.
Mhm.
Again, it's in the hands of that, but it still helps to be very familiar with it in case something like that pops up. So it'll be fine. So
Yeah.
I don't freak out anymore when I see a topic passage over something that I don't know, because I know there's still going to be half of the questions that are going to be pseudo discrete based on other subjects or topics.
Mhm.
It's just a huge red question mark when genetics is like the sole.
Mhm.
But it's fine. Other than that, I can reason my way through. But
Yeah. Awesome. Well, good luck with all your practice then this week, and just let me know how all of that goes. Um, yeah, I feel like for our last meeting, or like next week, we can just target like trying to think if we want to do like new stuff together, just like go through passage together
Mhm.
and kind of go over that, or but you can also bring questions if you want from like, hey, I did this passage, like how would you dissect this kind of thing.
Mhm.
But I definitely want to focus on like, here's how, let's break it down, let's
Right.
approach it this way.
Yeah, I agree. I think that'll be good.
Awesome.
Cool.
Cool. Well, have a good week. Good luck with all your studying.
Thank you.
Okay.
Don't stress about catching up either.
I'll try. I won't stress. Senioritis.
Yeah, I bet. Yeah. It was like, oh, I'll just take it as it comes, finish it, move on.
That'll be what it is. Yeah.
All right.
All right. Cool. See ya.
Bye.